Hey, look at this. I've got one of those Gigatron things. You know, the computer that just uses 7.4 series logic. Oh. Oh, it comes in a little box? Oh, sweet. Looks like a clone Famicom controller. Instruction manual, stickers, and oh yeah. Pluggy McPlug face. Oh, this must be the PS2 keyboard adapter. They've laid out the chips in the foam in the basic arrangement that they go into the PCB. Smart! Yeah, so all this is RAM and a ROM. The CPU itself, which only has 8 instructions, I believe, is created by all these other additional logic chips. I read through the instruction manual last night. Quite a bit of it is just how to install the components. The second half of it has the schematics and the theory of operation, as well as some code in C that acts as a simulator. So really, it's a very, very simple processor. Clock generator. Alright, so you can have a crystal here, a couple of resistors, and it's going into this inverter, NOT gate. And what that will do is it'll take the sine wave of the crystal and turn it into a square wave that can be used to drive the clock of the entire system. Also, right next to it we see a 74HC595. That is a shift register. So what I think is happening is they're taking the shift register instead of the Nintendo controller, clocking its bits out into this shift register, and then this is a serial in parallel out shift register, so then the output of that is put onto the main bus. Oh, I really like the foam stuff they put these chips in. You can like squish it and it goes from hard to stiff. It's really satisfying. Alright, I'm going to start with these up here. Yes, so yeah, bending the pins is handy. It's the part you've all been waiting for. Soldering. Ooh. Need extra heat for these ground pins because there's a lot of ground plane. Therefore, heat from the iron sinks into that plane and takes longer to actually melt the solder. Because you know what they say, the bigger the glob, the better the job. I wonder if I made a video where I solder every point on video. I wonder if anyone would watch all of that. Because, you know, YouTube is more about watch time than view clicks. Nice. Next we have some 74HC161s. That's a 4-bit counter that is presettable. That means it doesn't just start at 0, you can make it start at anywhere from 0 to 15. Which is good because as far as a program counter is concerned, that way it could be set to a value so it can jump to another position in memory. 4 4-bit counters is, you know, 16-bit bus gets you 65535 memory locations. You know what? Screw it. I'm going to record every pin being soldered on this thing. And if I made a mistake, let history be the judge. Yeah, all these solder blobs, they should look like nice little Hershey Kisses. Nice little droplets of love. Boy, there's a lot of soldering to do. Maybe I could tell another story. Oh gosh. I mean, I've got so many stories. Not all of them are appropriate for YouTube, though. A lot of them aren't. Gas prices are pretty low. That's something we could talk about. Think about inflation, it's quite low. Heck, 25 years ago, we were paying like $1.39 when I was in high school. I wish I paid the same rent when I was in high school. Of course, video games only cost $10 more than they did when I was in high school. Because I can remember, I was doing chores and working jobs to buy my video games in the early 90s, so I know how much they cost. I know they were only $10 cheaper than they are now, 29 years later. And that's why there's DLC. Okay, 74HCT377 is the Y register. I'm guessing this is going to be some sort of buffer or flip-flop that will store an 8-bit number. Yep, it's an octal D-type flip-flop with data-enabled positive edge trigger. So basically you got 8 in and 8 out, and there's going to be a clock line whenever that's pulsed. The inputs are moved to the output and held there. So you could think of it as a 1-byte RAM. So a CPU is going to have multiple registers in it, like an accumulator, X register, Y register, that way with 2 registers, that way they can add them together and do things with them. Oh, this reminds me of a story. I was on a fishing trip with some friends, and someone looked at this news story on their phone, and it was like, boat crashes near Taiwan. 50,000 flip-flops wash ashore. And I said, oh, I didn't realize integrated circuits floated. 74HC157, there's 2 of these. This is a quad multiplexer. So there's going to be 4 lines in and 8 lines out. And then there's an enable line, right? So if you think about it, there's 4 pairs coming in and 8 pairs going out. And the enable line, if it's high or low, that says whether or not those 4 pairs either go to one half of the 8 outputs or the other half. So think of it as 4 lanes of traffic, and each lane can be split in 2 directions. That's what this multiplexer is doing. So I place in the chips, I'm going to hold them, give them a squeeze, put them down upside down, and then press to make sure they're being pushed flat up against the PCB and level with everything else. Let me level with you. I don't always do this, but it's also helpful if you just pin the corners like that, very much like screwing drywall to the wall or something. You get the 2 corners to hold everything straight, and then you go in and do the additional supports. Because otherwise what can happen, especially in this case, is if you tilt it back and forth, it can cause the chip to tilt up and down, and some of the pins might not be as far through as others. I mean, it'll still work, it'll just look janky. I wonder how much lead is in my body. I was watching that Today I Found Out video, and they're talking about how Isaac Newton was into alchemy, and they analyzed his hairs, found out he had like ridiculous amounts of mercury and lead in his body. They said it made him cantankerous and bipolar. I guess that could explain a lot of things with me. X register is once again the 161 counters, so that's a pair of 4-bit counters, so that's a 8-bit counter, and it's combined together. Low address, that's some more 157 multiplexers, just like the high address. So really the X register is kind of the odd man out here. Press down the chips, flip it over, press down again, and solder. I needed to get a new sponge. My sponge is really crappy. Sponges are like not expensive at all. I've got a bunch of them under my sink. It would take almost no effort for me to put a new sponge in my soldering station. Why don't I? I have no good answer. Laziness, I guess. That's not really an excuse. It's a reason. Yeah, you can also do it this way. I mean, it works. I think what a lot of people get scared of with soldering, especially surface mount, is they think you have to actually be that accurate and, you know, solder every pin individually, but you don't. Especially with surface mount, you just kind of flood the area and then you remove any excess solder. This is kind of like TIG welding, except for this is a lot easier than TIG welding. Now, if you want to talk some next level Zen stuff, TIG welding. I'm going to install the 1 megabit program memory, which equals 128K bytes. Oh, they pre-socketed it for me. That's nice of them. Actually, you know what? I am going to install the 2 socketed chips last, because otherwise it's going to change the height of the board and then prevent this from holding the chips properly. Haha, bullet dodged. Just like that one movie with Angelina Jolie where they bend the bullets. Hackers! So about these product numbers, 7.4 is a series of logic. H means it's high speed. CT means it's TTL level. And then the number at the end is just the actual, you know, identifier for the logic itself. And if you have this where it says SN in the front and N at the back, that just means SN is the manufacturer, Texas Instruments in this case. Oh, okay, anyway, so these are a pair of flip-flops. They're pretty similar to the other flip-flop that we installed, except for these have a reset line. So I guess you could pulse one line and make these 0 instead of having to load more data in order to clear it. Maybe in the video thumbnail I can say, Gigatron, watch me solder every pin. Actually, that would be a good thumbnail. And of course have like a big dumb red arrow pointing at something. And if you can, have like a red circle around something. That's important too. You won't believe what's inside the Gigatron, right? Top 10 Gigatron programs. I could do this all day. You won't believe what insert 80s TV star looks like now. Wow, I could just generate clickbait. Got like a random clickbait number generator in my head. Just like Johnny Mnemonic. See, I just bring the iron and the solder together at the same time. I know you're supposed to heat the pin up first, but this works. Okay, 74HCT244 is, unsurprisingly, a buffer. It's an octal buffer, but it actually has 2 pairs of 4, so you can enable one pair of 4 or the other. So what a buffer does is it basically either connects everything or it doesn't. And then if it's not connected, it's in what's called tri-state, where the pins aren't 0 or 1, and they don't affect anything else on the bus. Basically, they're neutral, like Switzerland, I guess. 74HCT139, that's a dual 74HCT139. That's a 2 to 4 encoder. Basically, you have 2 bits coming in as the input, and then there's 4 possible outputs. Normally, they're all high, but depending on what the 2-bit input number is, one of those outputs will be low. So if you want the 4th output to be low, you would input 2 1s. Yeah, that's probably going to be used as some sort of selector. So selecting, it's using 2 bits to select one of 4 possible chips or peripherals. I've always wanted to try eating a cuttlefish. The one time I had an opportunity, for some reason I just thought it was going to be really salty, so I didn't order it. Have you eaten a cuttlefish? Was it salty? Tell us in the comments below. Oh, and I don't mean salty like the word everyone on YouTube likes to use because I assume some comedian used it 2 or 3 years ago. I mean sodium. Oh, there's even more decoders. Oh, you know what I bet this is doing? You have like an 8-bit opcode, right? And each part of the opcode is affecting different things. The addressing mode, the actual instruction itself. See how the instruction says 5 to 7? That means bits 5, 6, and 7. That's 3 bits, 8 instructions. Math checks out. Anyway, yeah, what it's doing, it's using these decoders to basically analyze each little component of an opcode. So in this case, you know, we're looking at 2 bits with that chip. This chip is looking at 3 bits. Oh yeah, so that's a 74HC138. So I know from memory that's a 3 to 8 encoder. Actually, there's 2 of them. All right, so yeah, so we're looking at 3 bits here, which is doing 8 things. 3 bits here, doing 8 things. 2 bits here, doing something, and then the 153. I'm not sure what that one is. Conditional decoder. To look that chip up. Didn't we come across that already? Anyway, all of these chips are decoding certain bits in the opcode and then selecting what to do based off those bits. So you're not just saying, oh, you know, there's 8 bits, there's 255 possible things. You're saying, okay, if the first 2 bits are set, that means one group of commands. If the next 3 bits are set, that means another group of commands, and then you slice up the 8-bit opcode from there. 74HCT153, this is a dual 4 input multiplexer. Yeah, we've never used one of these before. It's taking 4 inputs, and the 4 inputs only have 1 output. We don't know how it works, only that it does. I guess I could just look at the schematics included in the manual. But you know what? I kind of like just guessing as I go here, right? Forming my own opinion and then seeing if I was right when reading the book. Now, you know, a real microcontroller or CPU would have all of this kind of stuff already built into it, and it would be a lot more complicated as well. But I think it's really cool how this thing shows the basic building blocks of computers. 74HCT138, I don't need to look that one up. I know it's a 3 to 8 decoder. It's a very common chip to use in old school micro computers, actually, you know, for decoding peripherals. Basically, yeah, there's 8 outputs. They're typically high. 3 bits of input. In binary, you just select which one of the 8 outputs you want to be low. The reason it goes from high to low is because most peripheral chips use low as the active enable. It was kind of serendipitous that the Gigatron people reached out to me when they did, because I was kind of thinking about doing another 8-bit computer project. Maybe something with the Z80 and the TMS 9918. Oh, who am I kidding? I'll probably still do that. But, you know, I had an itch, and this came along to scratch it. You know, it's like you're walking down the street, and you're like, oh man, I got an itch. And then, fortuitously, there's like a fire hydrant or a phone booth or something, and you're like, oh, I can rub myself against that. Okay, granted, you probably wouldn't find a phone booth anymore. Poor Superman. I guess Superman would have to go into a Sprint store in order to change. 74HCT32, so that's standard logic gate, that's an OR. It looks like they made an AND with some diodes and a resistor. I wonder why they didn't add another chip. Probably because they're already using a whole mess of diodes and they're like, hey, we could cut one chip, just use some of the diodes we're already including. Is Ben really going to make us watch him solder every pin? The answer to that is yes. Maybe this could be like soldering, what is it, ASMR? One of those like made up terms that they want you to think is real, but it's just a bunch of BS. 74HCT240 inverter. It's probably an inverting buffer. I'm gonna take a look. And yes, it's a octal buffer. Again, it's 2 pairs of 4 with 2 separate enable lines. Octal buffer, and it's inverting the output. I imagine that's probably part of the opcode and decoding method, and they're just using this instead of 8 OR gates. Because if you have, what would it be an OR gate? You'd have a quad OR. Like if you had a chip like this, that's 4 OR gates on the chip. And this, well, Well, this is smaller than 2 of those chips, you know, 2 times 4. But again, I'm just guessing. Again, I'm going to install these diodes later. I'm going to work with the lowest components and then work my way up. Arithmetic and Logic Unit, ALU. Using a bunch of those 748CT153 4-input multiplexers. Got the data sheet for here. Yeah, that's a truth table. It's kind of weird. You really only have 1 output and 4 inputs. It seems almost like it's being used to index or, you know, do some sort of logic, conditional logic. Each one of these 4 to 1 multiplexers represents a bit in the logic arithmetic unit. Oh, so this must be able to do what? And or XOR, addition and subtraction. There's a buffer in the middle. So this is probably taking data off of the bus. These chips are arbiters of how it goes into the adders and the accumulator. And then once the computation is done, then I assume it's put back onto the bus. We have a 377, that's an octal buffer. And this is an octal buffer with reset. Extended output, so I wonder. That's probably either going to be a high byte or used for flags. Like, you know, if you add, you know, 200 to 200, it's going to be more than 255, which would incur a carry flag, for instance. So I wonder if that's stored in that other flip-flop. High adder, low adder, I'm guessing these are both 4-bit adders with cascade. So when you combine them, it becomes an 8-bit adder. See, one of the things that can slow down an 8-bit processor are things like 8-bit addition and carry flags, etc. Because, you know, if you're adding 2 numbers together and the result exceeds 8 bits, then that number has to be stored in more than 1 byte of memory. You actually have to figure out the remainder in order to get the actual number. And that all takes time, whereas with a 16-bit or 32-bit processor, it's much more likely that all your computations will fit within the bus width of the processor itself, therefore reducing additional cycles. I gotta like scrape the ice off my car. I have to go to the post office later. So icy here. Had a bunch of snow, then a bunch of cold. Then it got warmer, then the snow melted. Then it got cold, so all the melted snow became ice. You just can't win. You ever notice certain things in the universe that seem annoying on purpose? Maybe it is a simulated universe or there's some sort of God, because there's so many cruel ironies in the world that seem beyond happenstance. Like how it's always your left windshield wiper that breaks. You know, the one that you look through, at least here in America. Why can't the right windshield wiper fail first for a change? Why do you hate me, simulated universe? Or the fact that it's, as a man, it's easier to grow hair everywhere on your body except the top of your head. Just not fair. Or maybe it's just humans looking to find patterns in the chaos as they think of things to say as they solder hundreds of pins. I've watched the 8-Bit Guy and Dave Jones episodes about this Gigatron. That's why I've been going into a bunch of detail about the chips, because I feel other videos have not done that. I've kind of wanted to build a like a graphics chip, you know, like a chip that can do either RGB, VGA graphics, or possibly NTSC, although it's more difficult. You know, like like a Nintendo PPU, picture processing unit. That'd be kind of cool. So the Amiga Computer, you've probably heard of that, I would assume, if you're watching this channel. When they were developing that, you know, they didn't have the money to make the custom chips because that's the most expensive part. So when they took it to CES, they actually bought a plane ticket for the breadboarded video chips. So they made the video chips out of hundreds and hundreds of, you know, integrated circuits like these, and then put it on a big breadboard, kind of like in Back to the Future when he rebuilds the time circuitry on the hood of the car. But they had these 3 big wire wrap breadboards that, you know, basically were the video chips, just not in silicon form. And they bought a plane ticket and they flew that chip sandwich to Vegas as a person. Basically, they strapped it into a seat. Then they got their funding, and then they could afford to get those designs that they knew worked made into their own chips. I mean, I guess I could look these up, but I mean, I'm pretty sure they're just going to be 4-bit adders. I mean, really, an adder is just an AND with carry. You know, if 0 and, you know, if you had 0 and 1, or 1 plus 0, each of those are going to be 1. But if you have 1 plus 1, if there's 2 bits being added, then the result is 1, but also it carries to the next bit. So if the next bit is 0 and 1, or 1 and 1, or whatever, the preceding bit is applied to it first, and then the math occurs. So it's basically cascading AND gates that are creating the adder math. The main thing being is the result of the previous bit being carried into the current operation. And now our computers all have AI and they're plotting our destruction. I'm sorry, Dave. I can't let you do that. Output register, it's another octal buffer. So you'd put a byte on the bus, and then you would clock this with, you know, your write command, and then the output would appear on the other side, allowing you to, you know, sample it with other things. I wonder if that's what's driving the VGA. I wonder. 2 bits of red, green, blue, and then H sync, V sync. Total of 8 bits. So this thing must be doing software driving of the VGA bus. What's the clock? There it is. 6.25 megahertz crystal. Okay, why is that number important? The minimum frequency to drive a VGA display is 25 megahertz. So 6.25 times 4, 25 megahertz. So what I bet they're doing is they're actually driving it at 1/4 the frequency. So there's going to be chunky pixels, but as long as everything happens at the correct time, it should be all right. Because, well, as you see here, VGA doesn't have a clock per se for the pixels. It only cares about the clock for the horizontal and vertical. So what they would be doing is they would be taking all the timing and dividing it by 4. And as long as the horizontal and vertical syncs are in the right place, it won't matter. You'll just have 1/4 the horizontal resolution. And see how there's 2 resistors per color? That is a resistor ladder. So you're taking digital, putting it through 2 different resistor values, which basically is a digital analog converter. So you get 2 shades of each colors. So you'll have 64 colors. All right, so this output register is just driving the video. Well, actually, you'd have to put data on this basically every clock cycle. I wonder if, well, I assume the VGA stuff is held in RAM. I wonder if it kind of like, you know, stupidly puts the output out. I'm not sure how many clocks each instruction takes on this. And before I move on to the passives, I'm going to install the RAM and the EEPROM, single EEPROM, since it's obviously got a window in it. Stay with me one more day. If we need to, one more night. My niece was really sad when Star-Lord got killed in Avengers. And then one of their cats died. Trash Cat. Who has been on the Ben Heck Show before. My sister got Trash Cat cremated, so I guess I could just tell my niece that Thanos killed her cat. Yeah, I wonder if they took the ashes of all the dead Avengers and put them into urns. Actually, after Thanos does his snap, you'd have a huge boost in the urn industry. Plus, on top of that, the labor force would be cut in half. So the people working in the urn industry would be earning a lot of money. The thing that was dumb about Thanos' plan, like on Earth even, you know, cutting the population in half would only set us back, what, 30 years? I mean, most of the population explosion has really happened in, you know, the last 30 years, basically since the 1980s. Oh no, Thanos killed my... Wait, is it Thanos or Thanos? You know what? Half the internet says Mario instead of Mario, even though Mario tells you what his name is. It's-a me, Mario. He doesn't say, it's-a me, Mario. So why do people say Mario? That's all the TTL logic. Now it's time for the passives, which will probably take just as long. Looks like there's a capacitor on each one of the chips for decoupling, and then a whole mess of diodes for the opcode decoding. VGA port, DB9. It's kind of weird to be soldering these into place. I'm usually removing them. Oh, tons of solder there. Oh yeah. That's what makes them so hard to remove. It's not the pins, it's the mounting pads. Oh, it's weird. They're using a DB9 instead of a Nintendo controller plug. Oh, I guess that off-brand Famicom controller does indeed have a DB9 on it. Did you know that VGA, or the VGA port, has I2C on it? Yes, 2 of the pins are an I2C bus. That's how it detects the model of your monitor. Even in the VGA days. It's kind of funny how VGA's probably going to outlive DVI. Oh, definitely outlive DVI. Kind of like how vinyl is going to outlive CDs. Who would have thought? Oh no, too much solder. Oh, an audio output port and a DAC, which is probably just another resistor ladder. There's also a PS2 keyboard adapter, which I believe simply uses a AT-Tiny85. That would be serial in and then serial out into the Gigatron. Here's a crystal. Nice. Oh, that's a big one. Look at that. Stuff like this, I like to grab the leads and then just get one in place, lift so it's flat, and then do the other. There's 3 47 picofarad ceramic capacitors and then 40 100 nanofarad. So the quantity 40, that's going to be the capacitor that's on every chip. So I'll just identify the 3 47 picos, install those, and I can just assume the rest are the 100 nanofarads. In what should not be a surprise to me, it's the clock circuit that uses the 47 picofarad capacitors, so I'll just install those first. So I think I'll just, I'll install all the capacitors, then all the resistors, then all the diodes, so I'll just do them in groups. I'm going to do here. I'm going to push it in, then just bend these. Oh no, did I move too fast for the autofocus? Curse you, Sony. So I'm just gonna hit these. And if I see the pad is touching the main ground plane, I'll make sure I give it more time. I just kind of have all the parts piled up over here. 1 mega ohm. 1 kilo ohm. 1 K ohm. No one ever says kilo ohm. Although that's what it is. Yes, that's right. Every connection. Even boring resistors? Especially boring resistors. Power connectors using USB Mini. I always liked USB Mini. I kind of feel, I don't know, micro feels, just feels like it will break. I always use USB Mini. Oh, see, it's not being used for data, just power. Didn't even hook the data pins up to anything. I mean, I guess they didn't really need to, although it may have been nice because that would have given it a little bit more, you know, holding power. It'll be fine. I do think it's kind of funny how there's this trend now where everything is powered by a 5-volt USB port, like all these retro consoles. You know, they're all 5 volts. But yeah, I mean, as people discovered with the PlayStation Classic, you know, you start drawing like over an amp, and a lot of phone chargers won't work, especially older ones. 3 resistors, 3 resistors, 2 resistors, assuming that's the VGA area. One thing you can do to make snipping these wires easier is to actually solder from the top. That way less of the solder blob is on the rear of the wire, letting you cut it a little bit more flush than you otherwise could. Of course, you run the risk of these solder connections not really matching the rest, and you know, having a fashion faux pas. But you know, that's life. Oh, I just said fashion faux pas in a YouTube video. See? So it's less solder blobby than the other resistors are. Looks like the rest of the random resistors are all 2.2K, which I assume are these. He's not going to actually make us watch him solder all the random resistors, is he? Oh yes, I am. The book said that it was going to include extra passives, but so far it seems like it's the exact amount. Maybe they realized it was pointless, and everyone's like, I've got plenty of these. I mean, I do that too. I'll order like diodes or something, you know, or like high power rectifiers for a power supply, and only need 1, but I'll order 3, and then you end up with this drawer filled with diodes. Didn't you just say you could solder the resistors from the front? I sure did. I'm not practicing what I'm preaching. Electrolytic cap, large diode. That's gotta be for the power supply. Oh, there's even a fuse. Oh yeah. I bet that's this guy. It's a pretty beefy diode. I assume they don't want anything attached to this Gigatron to backfeed into the 5-volt power supply. Oh wait, no, it's going to ground. Never mind, it's doing something else. And now to solder in all of the random capacitors. Oh wait, I said you can watch me solder every pin, but you don't have to see me insert every pin. Okay. I think I can do a jump cut here without running into false advertising issues. I think that's all the capacitors. Now, to solder them. Uh-oh, that's kind of close to that. Don't want to do that. Do that. 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 There's no rhyme or reason to my actions. There's no earthly way of knowing. It's pretty much one capacitor per integrated circuit. Kind of drives home how many integrated circuits there are. I mean, it didn't seem like a lot until I had to add capacitors for each one. Then I'm like, whoa, whoa, whoa. What's going on here? Oh, that's a mess. That'll work. If only I had a selective solder robot. Selective solder, it's like imagine like a fondue station, but with solder. Molten death. The fires of Mount Doom. It was around that time Ben's promise to show everything being soldered seemed a bit much. But Ben, speaking in the third person, could not turn back now. He promised to show everything, even if the water heater turned on and made noise in the background. Wait, I think that's the furnace condensation pump, not the water heater. Oh, there's another one. So bending the pins over is handy for keeping the components in place, but then you have to make sure they're not going to short out to anything else. Some feedback on this. I think these decoupling caps may have been better served as surface mount parts. That may have scared some people, but let's face it, like a 1206 surface mount cap is not that hard to solder. It would have taken up no more space than the through-hole parts, and you'd have a lot more room on the back of the unit to run traces. Also, all of these, snipping all of these lines was kind of a pain. Also, bending them over in close proximity to other I/O increases the chance of a short circuit. So I would say that's my major feedback so far. All of these should have been surface mount. You were planning on having transistors in your transistor logic microcomputer, and that's the essence of chaos. I don't know where those leads are going. I don't care, as long as they're not stuck on the bottom. Looks like a couple of resistor arrays in the decoding area. Seem like they'd fall out easily. I'm going to just tap that corner there, flip it, and then finish it. A resistor array for the LEDs. They're using the same resistor array for this as they are the logic. The other resistor array looks like it's being used for this DAC, digital to analog converter. And then the last two capacitors as a high and low pass filter. Oh, again, yeah. Exactly the number of capacitors needed. Oh, I see they have test points. That's cool. I wonder if you can single step this thing. Like have a push button and just clock through all of the different cycles. Manually, very slowly. Excruciatingly slowly. And I don't really care for these LEDs either. They don't have flat bottoms, so it's going to be kind of hard to make them all lined up equally. 5mm LEDs don't fit. They're too close together. Yeah, I'm going to use these 5mm by 2mm green LEDs. I want them to stand straight. All right, let's do this. Let's go and just put a little bit of solder in each one. Not both pins. Nope, those two I didn't do a good job on. Put a little bit of solder on one of the pins of each LED. Your work here is done. Great. Okay, now I'm going to do, on the other side, I'm going to push it with my finger. Bring it forward. Do that with each one. Same thing here. These are a little trickier because they're rectangular, which means they don't, they're not a circle, so they're not going to sit as flat. So they're going to tilt a little bit. Well, that's acceptable. Now that I have them the way I want them, I will solder the other side. I'll use one of their lame LEDs for the power indicator since there's no other LEDs near it for you to see how crooked it is. And after this, should just be the diodes. But Ben, LEDs are diodes. Memory is RAM. What show was that from? Leave your answer in the comments below. Complain about my thumbs in the comments below. Complain about how I pronounce words in the comments below. Got all of the decoding diodes in place. Ugh. This is even messier than the capacitor thing. Gross. But it must be done. It had to be done. That's on you. Ugh. I'm even gonna do this. I swore. I swore I'd show every connection. Can't stop now. I know. I'll bend them up as I solder them. That'll make it slightly less horrible. And it'll just be slightly horrible. That's a short circuit waiting to happen. I still hope my diodes look nice on the other side. Oh man, this is so messy. And normally I'd trim these later, but I need to trim them just to get at the rest. Again, this is something where surface mount diodes wouldn't have been that difficult to, it's not that difficult for people to place. I know a lot of people are scared of surface mount, but it's an unfounded fear. I think I can work with this. Every connection. Every connection. Snake it in there. Yeah. We're getting close. I can see the finish line. I can go the distance. Can I do it without having to stop and snip again? Or bump the camera? I think I can. I've always wanted to try you, Dalton. I think I can take you. It's always Barber College. I did it! Only some of the diodes are lopsided and ugly looking, but you know what? I'm okay with that. The Gigatron is fully assembled. In a future video, we'll get it running and see what it can do. Stay tuned.